Hi, my name is Kaela Fennell-Chin, and I'm doing interactive learning number 3. And my first problem, I'm asked to find the local extrema for my function x plus 1 over x. So first we have to know what local extrema is. And to find local extrema, you want to take the derivative of your function and find where it's equal to 0. So that's what we're going to do first. So f prime of x is equal to, and to take the derivative of x, you're going to use your power rule, and right now x is to the power of 1, so if you subtract 1, it's going to be 0, but you're multiplying by 1 first, so you have 1 x to the 0, which is no x, plus, and this can also be written as x to the negative 1. So if we were to add 1 to subtract 1 from negative 1, you get negative 2, but you're going to multiply by negative 1 first, so negative 1 x to negative 2. And if we were to rewrite that, you'd have 1 minus 1 over x squared. So now we're going to set our derivative equal to 0. So if you have 1 minus 1 over x squared equal to 0, you're going to subtract 1. 1 over x squared is equal to negative 1. You're going to divide by negative to make this side positive. 1 over x squared is equal to 1. And then you can multiply by x squared, so 1 equal to x squared. You can take the square root of both sides. Then you have x is equal to plus or minus 1. So now we want to test these points, because this is where our original intersects at the x-axis. So if we were to test these points at negative 1 and 1, which tests something over here, so let's say negative 2. If you were to plug negative 2 into our derivative, you would find that it would be a positive number. So negative 2 squared is 4, then 1 minus 1 over 4 is going to be a positive number. Then if you were to plug in, let's say, negative 1/2, you're going to get a negative number. And then if you plug in 2, you get a positive number. So it kind of looks something like this, just to look at the slope of everything, because it's increasing, then decreasing, then increasing. So at your negative 1, you're going to have a max. And at your 1, you're going to have a min. So this is what it would kind of look like for the derivative of it. And we're trying to find our local extrema. And the reason that it says local is because since it does not give you a certain endpoint, that means that your graph is going to continue all the way to infinity. So you're never going to have a global extrema. So our answer is going to be our local max will be at 1x is equal to negative 1, and our local min is going to be when our x is equal to 1. So what we just found is that this graph, which I'll kind of graph it for you and show you what it looks like. If this is it, you're going to have something kind of like this. So what it's saying is that on your graph, where our local max is going to be is kind of right here, because it's like a point where it's critical. So you have 1, negative 1, and 1.